So now we've got a shader that simulates global illumination. Our shader supports a light map, and we're applying our ambient occlusion in the light map slot. And our shader also supports an ambient cube map, and we've placed our ambient cube map in that slot. So the result is some really nice, realistic looking lighting. Now the main thing that's left is we need to learn how to create these cube maps. I've only supplied one set of cube maps on the DVD, and I want to explain to you how these cube maps are created so that you can put objects in your own environments and use the lighting from those environments instead of just the single cube map that I've included on the DVD. So like I explained before, the cube map represents the light coming in from the environment. So if you're using a cube map from my backyard, for example, and you put your object in your own environment, it's not really going to look like it fits into that environment. So you need to create a cube map that's unique to each environment that you put your models in. In this chapter, we're going to go over two different methods of creating these cube maps. The first method we're going to go over is how to create a cube map that has light from the real world or from reality. And the second method we're going to talk about how to create a cube map that contains light from a virtual environment, from a game environment, for example. So first, let's focus on how to create cube maps from real world lighting. In order to do this method number one, the first thing that we have to do is create a light probe. And this image here is a light probe image. And I'm not going to go over the specifics of creating a light probe on this DVD, but I will include some links to some tutorials on the web where you can learn how to create light probes. Basically, it boils down to putting a mirror ball, like a chrome sphere, in your environment. And here you can see that I've got a chrome sphere that I've placed in my backyard. And I just placed it on this blue water container because I didn't have a tripod for it. But basically, you just take several different exposure levels of the chrome sphere, and then you combine them all together into a single image in this program called HDR Shop. And I'll include the URL on the DVD for where to download HDR Shop. So we're going to be using HDR Shop to manipulate our image. When we combine these exposures together, they create what's called a high dynamic range image. And the thing that's special about high dynamic range is it's not just containing colors from 0 to 1 or 0 to 255, for example, but it's actually including all of the light measurements. So every pixel here is not just a color, it's actually how much light was coming in that particular spot. So if we look over here, you can see that this area is bright, and we also have some areas here in shadow that are really dark. If we move our exposure, we can see that this area here, there's a lot of detail in that area, but if we move the exposure up, that detail gets washed out, and we can actually see the detail that's in our shadow areas. So we have a high dynamic range image here that contains both, the mid-range tones and also the really high tones and really dark tones all together in one image. So this is what we're going to start out with. Now, from here, once we have our HDR image, the first thing that we need to do is convert this to a latitude-longitude map. So I'm going to go Image, Panorama, Panoramic Transformations. And I'm going to use this little window here to convert our HDR light probe into a latitude-longitude map. So from here, I'm going to pick light probe angular map because that's what format this image is in. And we're going to convert it to a latitude-longitude map. And at the same time, I'm going to scale it down to 256 by 128. My original image is 1825 by 1825, so fairly high resolution, but I'm going to be scaling it way down, and I'll explain the reason for that scaling down in a minute. I'm going to go ahead and hit 8 samples or super samples to just give us a higher quality result. I'm going to hit OK, and it's going to process it, and you'll notice it spit out a latitude-longitude map here for us, which is basically just a different type of projection. For example, if you're unwrapping the globe or the map of the world from a sphere into a flat map, you might see a latitude-longitude projection used for that. And that's what we've got here. So you can see my house here and some other buildings. And it's basically a latitude-longitude map. So from here, what we need to do is convert our latitude-longitude map into a diffusely convolved map. What diffusely convolved means is that instead of each pixel representing the color that's coming from that one specific direction, I'm going to take all of the pixels in a 180-degree hemisphere in that direction and average them all together. So each pixel, instead of representing that one specific direction, will be representing the colors coming from a 180-degree hemisphere in that direction. And that process is called diffuse convolvement. And a diffusely convolved cube map is what we need to make our cube map ready for lighting our model. If we were to use this image as it is to light our model, what we'd end up with is a reflection map instead of a diffuse light map. So I'm going to go ahead and under Image, pick Panorama, Diffuse Specular Convolution. And it says, notice here that it says it's going to take 1,536 seconds. Diffuse convolution is a process that's fairly mathematically intensive, at least when you do it with the method that HDR Shop is using. And that's the reason I scaled our latitude-longitude map down a lot, because it's going to take about 20 minutes to process this image. And so I wanted to go ahead and scale it down. If you do a larger one, it can take all day to do diffuse convolution. Anyway, so I'm going to leave our Phong exponent to 1 because we want a diffuse convolve, and I'm just going to go ahead and hit OK. And so HDR Shop is going to think about this, and it's just going to keep thinking about it. And like I said, it's going to take about 20 minutes. So I'll go ahead and pause the video here, and we'll start again when it's done. All right, so our diffuse convolve filter is done, and you can see that our result is a very blurry version of our latitude-longitude map. Now this is why it doesn't matter that your resolution is relatively low, 256 by 128, because there's pretty much no detail in this diffusely convolved map at all. Basically, each pixel on here represents all of the data coming in from a 180-degree hemisphere instead of one very specific direction. So from here, I'm ready to convert this to vertical cross format so that we can then save it as a DDS cube map. So I'm going to come up here again to Image, Panorama, Panoramic Transformations, and this time we're going to convert it from a latitude-longitude map into a cubic environment vertical cross map. And again, I'm just going to keep my resolution relatively low. Say our height will be 256 and the width will be 192. And again, we'll set our samples up high so that it's nice quality. And I'll hit OK. And it's going to convert our latitude to longitude map to a vertical cross format. Now, if my game engine supported cube maps in vertical cross format, I could stop here. But in Max, Max only supports cube maps in DDS format. And so I actually have to save it out of HDR Shop and bring it into another program so that I can convert it to a DDS cube map. So I'm going to go ahead and pick File, Save As. And we're going to save this in radiance format, HDR, because we want to preserve our high dynamic range data. And I'm going to save this as Ben's Backyard vertical cross.hdr. Go ahead and hit save. And I'll replace the one that we already have there. Now I'm going to bring up a new program, and this program is called Cube Map Gen. And Cube Map Gen is a piece of software that was created by ATI, now owned by AMD, and you can download Cube Map Gen for free from the AMD website, and I'll include the URL on the DVD. So what we're going to do in here, this software is used for converting our vertical cross cube map into a DDS cube map. And in this case, all I need to do is say load cube cross, and I'll pick Ben's backyard vertical cross.htr. And we already had it loaded up actually, so it doesn't show any changes here. Now I need to save it out as a DDS cube map, but before I do that, I'm going to choose my output format, and if I save it as 8-bit RGB, that's not high dynamic range, that's standard dynamic or standard range. So I'm going to choose float 16 RGBA rather. I'm going to hit filter cube map, and then I'm going to hit save cube map.dds. Now I can save out my cube map as a DDS file. And I'm going to go ahead and save it over the top of C Ben's backyard 16d.dds. So the C underscore stands for cube map, and then Ben's backyard 16d. 16 stands for float 16, and then D stands for diffuse. I'm going to go ahead and save it as that, and it's saved. Let's jump back over here to Max, and in my Ambient Cube slot, I'm going to pull this up and pick Ben's backyard 16D that I just saved, and you'll notice that it looks exactly the same. So all of the steps that I've just told you complete the process of creating a cube map from reality. So if I want to use light coming from the real world, this is the method that I would use. So we start out in HDR shop, create a latitude-longitude map, convert it to a diffusely convolved map. Then we convert it to vertical cross format and save it out. We bring it into cube map gen and save it as DDS cube map. And that's the whole process. And once we've done all of that, then we can just load it right onto our model in Max. So now let's talk about the second method for creating cube maps. And the second method for creating cube maps allows you to create cube maps from virtual environments. So what I'm going to do is bring up this other copy of Max that I've got running. And what we've got here is a virtual environment that I created inside of Max. So we can just fly around in here and see that we've got this nice environment. Now what if we want to create a cube map so that our object will look like it's being lit by this environment? How do we do that? Well, what we need to do is create the 6 sides of our cube map. And in order to do that, I'm going to create a new camera, and I've already created it in this scene. I named my camera Cube Maker. And let's see, where's my camera Cube Maker? So before, I was using this camera to create a cube map for this reflective sphere here. But I'm going to go ahead and grab this camera and move it out of my sphere. And you'll notice that it's pointing straight down. Now there's a couple of things that you need to know about this camera. First of all, I set my field of view to 90 degrees. And that's what I need to capture each of the sides of the cube. And the other thing that I need to do is come up here under rendering and set my renderer so that the width and height are the same, so that we get a square image. Now I'm going to set my camera to Camera Cube Maker and turn on my shaded view. And now I'm going to enable show safe frame, and this will make my image square, or the same aspect ratio as my settings here. So what I need to do now is configure safe frame so that I turn off these extra lines and hit OK. And now we've got a nice square image. So if I hit print screen and do a screen grab of this, then I can bring it up in Photoshop. So what I want to do is, so this image here would represent the bottom of the cube map. So what I need to do is grab one to represent the bottom of the cube map, and then I'd grab my camera and rotate it 90 degrees I'll turn on rotation snap to help me out with that. Rotate it 90 degrees. And this image here would represent the front. So I do a screen grab of that. And then rotate it up 90 degrees. And this image here would represent the top. And I would go ahead and keep rotating my camera and taking screen grabs and pasting them into Photoshop until I had all 6 sides of my cube. And I went ahead and did that just to kind of save us some time. And so here I bring up Photoshop and show you, here is the image that represents the front. And I went ahead and cropped my screen grab so I just have that one square image. So here I've got all 6 sides. And once I have these images, I'll save them in TGA format. And on the DVD, I'll also include these 6 images so that if you just want to practice with the ones that I created, you can do that. Now, once I've gotten to this point, I need to go ahead and jump back into Cube Map Gen and load these images in. So let me go over how to do that. So here where it says Load Cube Map Face, this is the feature that I'm going to be using to load in the 6 individual sides of my cube map. So with the first method of creating cube maps, we use this Load Cube Map Cross. And this time we're going to be, instead of loading across, we're going to be loading each face of the cube map individually. So before we do that, we first need to select which side of the cube we're going to be loading. In this case, Z positive is going to be our front, and Z negative is going to be our back. So let's load the front face first. So I'm going to pick Z positive, and then hit Load Cube Map Face. I'm going to go into the folder called Cube Map Sides and pick Front. So now we've got the front of our cube map showing here. There's a handy little checkbox here called Skybox, and if I check this, it's going to show us that, or it's going to use the cube map for our environment, not just apply the cube map to the sphere, but also put the cube map on the entire environment. And that's going to make it easy for us to line things up. Now I'm going to set this to Z negative, and then click Load Cube Map Face and pick Back. So now we've got the back side of our cube map. Then I'm going to set this to Y positive and hit Load Cube Map Face, and Y positive is our top. So you can see that our top face came in, and then obviously Y negative is our bottom. So I'm going to pick the bottom image, and the bottom came in. And then I'm not really sure which is which with X positive and X negative. I'm just going to guess that X positive is the right side. I may be wrong on this, so we'll see. Nope, I guessed right. So X positive is the right side, and X negative, Load Cube Map Face, is the left side. So I've got all 6 sides of my cube loaded in, and you can see that that looks pretty nice. So we're ready to compile these into a cube map. Now if I wanted a reflective cube map, at this point I could just say save cubemap.dds and I'd get a reflective one. But what I really want is a diffusely convolved cube map, and I can do that in Cube Map Gen as well. So here's how you do it. First of all, I need to come in here and set filter type to cosine. And then I need to set my base filter angle to 180. And what that means is that each pixel is going to represent the light coming in from a 180-degree cone. If I wanted to make it narrower than that, I could, but I need to use 180 to get the results that I'm looking for. So now I'm just going to hit Filter Cube Map, and it's going to go through and do all of the math necessary to filter this. And you can see that it's counting the percentage done here. And it's going to take a little while, so I'll go ahead and hit pause and come back when this calculation is done. So my cube map is all done calculating. It's now diffusely convolved, and you can see that it's pretty blurry. And I'll go ahead and I'll say save cubemap.dds. And this one I'm going to call see my new cubemap.dds. So go ahead and save that. And now I'll go ahead and bring up Max and my teapot. And this time, instead of see Ben's backyard 16d.dds, I'm going to load on in the content folder of chapter 10. I'm going to load on my new cube map.dds. And you'll see that my teapot got quite a bit darker. And that's because that particular environment was pretty dark. I'll go ahead and assign it to my plane here as well from chapter 10, my new cube map.dds. And so now my teapot and my cube are being lit with the lighting coming from this environment. So there you have it. You have the two methods for creating cube maps to light your objects. So with the first method, you use a light probe that's captured from the real world. And just to kind of summarize the second method, you take screen grabs from a virtual environment with your field of view set to 90 degrees, and you bring those screen grabs into Photoshop, and you crop them so they're square, save them out, then you load them into Cube Map Gen using load Cube Map face and the different directional faces, and then you filter them using the cosine filter and the base filter angle of 180, and then save it. So once you're done with that, you've got a cube map that's taken from your virtual environment and applied to your object. So your object looks like it's being lit from every direction from the virtual environment. So there you have it, two methods of creating cube maps. So that wraps up this section of the DVD where we talked about global illumination, we talked about ambient occlusion, we talked about diffusely convolved cube maps, and now we're ready to go on to the next section. In the next section, we're going to go over alternative lighting models. We're going to talk about Oren Nayar and Cook Torrence and Phong lighting, and these are different ways of calculating the lighting. And the reason that we do these different ways is so that we can approximate different surface properties. So that'll be in the next section of the DVD.